Hi, welcome to ACETutoring's SAT Math Prep Series. I'm Anthony, and today we're going to be covering the top must-know SAT math concepts that will boost your SAT score. The first concept that the SAT loves testing you on is linear equations and systems. You'll see problems like this, where you have to know the fundamentals of the slope-intercept form, y equals mx plus b. If we read the question, then we see that they're asking for the slope of line J, and we're given that line J is perpendicular to line K. So we must know that if a slope is perpendicular, that means that it is the opposite reciprocal. And since our slope is negative 17 over 3, we know that our slope must be 3 over 17. And so that is the answer. Here we have another nonlinear equation, and we're asked to give the value of f of -1. And this question is actually quite simple because all you have to do is plug in when x is -1. So f of -1 would just be equal to -1 cubed plus 3 times -1 squared minus 6 times -1 minus 1. And when you compute all of that, we get -1 plus 3 plus 6 minus 1, and that comes out to 7. So our answer is just C. The next thing you need to know on the SAT is the circles equation. So for this, we need to know what the value of A is, because they're asking what is the value of A that's possible when this lies on the circle. So in this equation, we can see that the radius is 11 because you just take the square root of this value, the last value, and the center is at -4, 19, because that's the x value here, or the h if you could think about it like that, x minus h plus y minus k equals r squared. So from that, we know that the parameters of the x value must be between -15 and 7 because the radius tells us that from the center point, the x values can only be within this range, -15 to 7. And looking at the answer choices, we can see that only B lands us a value between those parameters. The next problem asks us what is the smaller value of two integers whose product are positive and equal to 462. And they're saying the first integer is 5 greater than twice the second integer. So how about we set up two variables? So let's make x the greater one. So x will be equal to 2 times y plus 5, and y will just be the smaller value that we're going to look for. So by doing this, it allows us to allocate only one variable that we're solving for, which is y. So let's just set up that equation. So it says we're multiplying them. So y times 2y plus 5 equals 462. That simplifies to 2y squared plus 5y minus 462 equals 0. If we go on Desmos, which is allowed on the new SAT, we can see that our X-intercepts are at -16.50 and 14.0. Since we want a smaller one that's positive, remember that -16.5 won't work because it's negative. So we will use the 14. And y cannot equal -16.5. Okay? So using that info, that's the answer. Next, we're going to be going over nonlinear equations. So in this equation, we're going to deal with a quadratic function, and it's asking us what is the minimum value of function p. So in these types of equations, it's important to notice that we want to have the p of x on its own side first. So p p of x is equal to x squared minus 57. So an important thing to know about quadratics is that the c value here is just the y-intercept. So it's 0, negative 57. And that makes it a lot easier to solve this problem now that we know that. So since we have a positive a value, it means that the graph will look like this, with both arrows going up, with a minimum value here. So the minimum value is just negative 57. So that is our answer B. Let's take this next question, which is slightly more challenging, but still tests us on linear equations and knowing our slope-intercept form. It gives us a table with 2 points, and we're asked to find the y-intercept, also known as the b value. Well, given the information that the y-intercept is at the point k minus 5b, we know that we can set k minus 5 equal to 0, because with our knowledge of the y-intercept, we know that it's in the form 0, comma, b. So when we set k minus 5 equals 0, we get k equals 5. Now that we know the k value, we have the point 5, 13 and 12, negative 15. Using that information, we can easily solve for the slope by using the y2 minus y1 over x2 minus x1 method. And we get negative 4 as our slope. Now that we have our slope, all we have to do is plug in the slope and a point in to solve for the b value. So I'm going to use 13 equals negative 4 times our x value 5 plus b. And we get b equals 33. And that's our answer. And finally, we have another nonlinear problem where we're asked to find which one is not an x-intercept of the graph of the function. So this is another simple one because we can see visually that the x-intercepts are just, there's 3 of these, so it's x equals negative 4, 1, and 3 halves, because all you do is set each equal to 0 and then solve. So for example, x plus 4 equals 0. We subtract 4 from both sides, x equals negative 4, and that's how I got these 3. And we just cross-check with the answers. So negative 4 we have, 1 we have, 3 halves we have, so the answer would be B because that's the only one missing. Thank you for watching. If you're interested in getting tutored by me for English or math, contact me at ACETutoring20@gmail.com.